So L'Hopital's rule is for when you end up with the indeterminate forms 0 over 0 or infinity over infinity. And the rule says that you're allowed to take the derivatives and then try to plug in the value again. Taking the derivative can help because it simplifies the problem. Every time you take a derivative, you go down a degree. So for this one, we're going to start by trying to plug in 0. E to the 0 would be 1. Cosine of 0 would also be 1, and here I will show you on the unit circle. I keep this on a sticky note I can just pull out. Here is 0 radians, right here. Cosine is the x value, so that is 1. All right, minus 0. And then in the denominator, if you plug in 0, you're going to get 0 minus 0, which is 0. So this goes to form 0 over 0. Which is multiple choice. You don't have to write that. No one's going to check your work on multiple choice. You just have to get the right answer. But you can't do the rule unless it comes out to this. So it's still good to check. All right, and so we're going to do the derivatives. So derivative of e to the x is e to the x. Derivative of cosine is negative sine, so the negatives are going to cancel. And then derivative of 2x is 2. And then down here, this derivative would be 2x minus 2. And so now we're going to try to plug in 0 again. So e to the 0 is 1 plus sine of 0. So here is 0 radians on our unit circle. Sine is the y value, so that's going to be 0. And then minus 2. And then down here, if we plug in 0, we'll have 0 minus 2, which is negative 2. You're not. Stop that. Right? So up here, 1 minus 2 would be negative 1 over negative 2. Negatives are going to cancel, so that one is positive 1/2, which is C. Although I can't blame you for saying things like that in the chat, because that's pretty much how I felt in every single class that wasn't math. So I remember what high school felt like. I do recall that feeling. All right, so this one's limit as theta goes to 0. Let me just write it a little bit larger here. 1 minus cosine of theta over 2 sine squared of theta. So if we plug in 0, again, cosine of 0 is 1. We're going to get 1 minus 1, which is 0. And then down here, sine of 0 is 0. So again, you just want to check that, because if it doesn't come out to that, then you can't do L'Hopital's rule. All right, but we're going to do the derivatives. Derivative of 1 is a constant, so that's gone. Derivative of cosine is negative sine, so the negatives are going to cancel. And then down here, this is going to be a chain rule. The squared is the outside function, and the sine is the inside function. So we're going to bring the 2 down. 2 times 2 would be 4. That drops to the first. You don't have to write the 1 if you don't want to. And then we're going to chain on the derivative of sine, which is cosine. All right, and so these signs are going to cancel. And so our numerator is just 1. There's nothing left there, so that's just 1. Down here, cosine of 0 would be 1 times 4 is 4. So 1/4, and so that one is C. All right, so over here, again, we're plugging in 0. E to the 0 is 1, so we'll have 1 minus 1, which is 0, and then the denominator will also be 0. So we are going to do the derivatives. Derivative of e to the h would just be e to the h. They used h instead of x, but whatever, just the variable. Minus 1 is a constant, so that's gone. And then down here, the derivative of 2h is just 2. So if we plug in 0, e to the 0 is 1, and so we get 1/2. So that one is B. All right, and then one more of these L'Hopital's rules. If we plug in 0, sine of 0 is 0. So that whole numerator is going to be 0. Denominator is going to be 0. So we get form 0 over 0. So we are going to do the derivatives. The numerator, what rule do I need for that, guys? What rule is this going to be when I go to do the derivative of the numerator? You know, you're like, she threw a question at us and it's Monday morning. Good, product rule, because we're going to have these two functions multiplied together. So good, product rule. All right, so that'll be the first function. So sine, they used x, not theta. Almost wrote a theta there. All right, the first function times derivative of the second. So derivative of cosine is negative sine. I keep drawing a theta. Changed it to x on me. All right, first times derivative of the second plus the second times derivative of the first, and derivative of sine is cosine. All right, over, and then derivative of x is 1. And again, this is why L'Hopital's rule works. You know, it's going to simplify things. So we can basically just ignore that. And now we're just trying to plug in 0. So sine of 0 is 0. So this entire first part here is just going to be 0. And then cosine of 0 is 1. So this would be 1 times 1, which is just 1. So that one is C. All right, so the rest of these are implicit differentiation. So none of the derivative rules have changed, but every time you do a derivative of a y variable, you have to multiply on, chain rule on a dy dx. We're going to do the derivative of each term, and just whenever there's a y, we'll put a dy dx. So derivative of 3x squared, that would be 6x plus, all right, now this is going to be a product rule. 2x is the first function, y is the second function. So that would be the first times derivative of the second, derivative of y is dy dx, plus the second function times derivative of the first. So derivative of 2x would be 2. And so this is your product rule. Plus, all right, derivative of y squared, that is 2y dy dx. And then be careful, derivative of 1 is 0. But I guarantee you there's a choice here where they left the 1 in, and they did. Look, see right there, they left the 1 in there. If you forgot, they're going to make that another answer choice. So you're evil. So just be really careful. All right, so that's all the calculus. Now we have to do algebra to get dy dx alone. So these two terms have a dy dx. I'm going to leave them where they are, and I'm going to move everything else to the other side. So I'm going to subtract over the 6x and the 2y. I'm going to subtract those to the other side. And these are a good bit of writing, so just be careful not to do a copy error. All right, and so I subtracted the 2y to the other side. Then we're going to factor out a dy dx. So greatest common factors, take that out. And then last step, we're going to divide the stuff in parentheses over. And so they simplified this, or reduced the fraction, basically. The 6 and then all these 2's, those will all reduce by 2. So I'm going to just divide everything by 2. It's the same thing as like reducing a fraction of 4/8 to 1/2. Just going to reduce the fraction. So this would be negative 3x minus y over x plus y. And then I think they also factored out this negative. So if you take that negative and put it out front, that would be a 3x plus y. They just took the negative and factored it out. So that one is B. And again, if your answer looks like a disaster, you probably did it right, because these are very messy problems. All right, now this one, we want to find the derivative when x is -1. So we have x, but we're going to need y. So I'm going to plug -1 in for x over here, and we'll solve for y first before I do the derivative. They gave me x, but I need y as well. So that'll be y equals, if x is -1, this would be negative y plus -1 squared would be 1, and then plus another 1. So I'm going to add this y over. That'll be 2y equals 2, and so y is 1. So we have x is -1, y is +1. We're going to get the derivative and then plug those in. So we're going to get the derivative and then plug those in. So yes, this one is going to also have a product rule for the x times y. So we're going to do derivative of each term separately. Derivative of y is dy dx. And then this will be a product rule. So first times derivative of the second plus second times derivative of the first. Derivative of x would just be 1. You don't have to write that. I just put that in there to show you the product rule. All right, and then derivative of x squared is 2x, and then 1 is a constant, so that is gone. Now there's two ways you can approach this. You can either get dy dx by itself, like do all that algebra, or you can just go ahead and plug in these numbers. My suggestion is just go ahead and plug in these values first. It is a lot easier to deal with numbers than variables. So I would plug these in, especially because 1 and -1 are going to be easy numbers to work with. So numbers are preferable to variables. So if x is -1, this is going to be -1 dy dx plus, if y is 1, this will just be 1. And then if x is -1, this would be a -2. So we're going to add this dy dx over. So dy dx plus dy dx would be 2 dy dx. And then over here we have 1 minus 2, which is -1. And then we're going to divide both sides by 2. So -1/2. So that one is B. All right, this one I think is the hardest one on here, in my opinion. Difficult and easy is always an opinion thing, but they said dy dx in terms of x. That means you can't have x's and y's all jumbled together. So the first thing I'm going to do, here, let me write this bigger. The first thing I'm going to do is get y by itself first, because it says in terms of x. So I want a y equals, and then the rest of the statement. So how would we cancel out an e? I want to get y alone. What do I do to both sides if I want to make the e, like what will cancel out as e, guys? And yeah, good, awesome, ln. So we're going to ln both sides. Nice job. So ln both sides. So this side's going to be ln of sine of x. And on this side, they cancel. That was the whole idea, and we get y. Now this next step, this is personal preference, but I know I can't be the only one that feels this way. Does anyone like it better written the other way around? Like y equals goes on the left? I don't know if that's just me or if anyone else feels that way. Yes, okay, good. I need it written that way. It just makes me feel better. Like the world just makes more sense that way. So it sounds like you guys are all type A like me. Okay, so I wrote it around the other way. And then we'll do the derivative. So it is a chain rule. It's like ln got hungry and ate sine of x. So we're going to do derivative of ln and then chain on derivative of sine. So derivative of ln is rational. It's going to be 1 over whatever you've got. And then we're going to chain on the derivative of sine. I'm just going to go ahead and put it in the numerator. And derivative of sine is cosine. And here's where during office hours, I realized I ran into a problem. This is what prompted me. I was planning on doing a whole lot of pre-calc review here anyway, but this is what really like lit the fire in me. I was like, hey, I need to do this because you guys didn't learn these identities. So like you would get here and then not know which choice. Now, you could have Googled cosine over sine and it'd have told you the answer, but cosine over sine is cotangent. And again, if you look through the very short videos I posted, I went through all the identities. The folder is called identities if you want to look through there. That is how that reduces. Sine over cosine is tangent, and they're just reciprocals of each other. So if you just flip that, that's how we get that. So anyway, that one was cotangent, so that one was C. And I know people were typing in the chat. Hold on a second. Let me read and catch up with what's showing up there. Yeah, I always have to flip this around. And yes, you're right. That's cotangent. Cool. All right. Nice. All right, last one. Now this one is asking for the second derivative and then at this point. All right, so we'll start with the first derivative. Derivative of x squared is 2x. And then derivative of y squared is 2y dy dx. And then derivative of 25 is 0. And so we're going to subtract over the 2x. And then divide by 2y. And so the 2's are going to cancel. We get negative x over y. All right, so now we're going to go and do the second derivative. And because this is a fraction, that's going to involve a quotient rule. So quotient rule is the denominator and then times the derivative of the numerator, which would be -1. Derivative of negative x would be -1, minus the numerator times the derivative of the denominator, which would be dy dx. And then it is all over the denominator squared. All right, so a few things. First of all, these negatives are going to cancel. And also, I need to replace dy dx with negative x over y. That is what dy dx equals, negative x over y. So I'm going to replace this dy dx with negative x over y. And then last step, we're going to plug in the numbers that they gave us, plug in this point. So everywhere I see an x, I'm going to put a 4. Everywhere I see a y, I'm going to put a 3. So that means this first part would be -3. Actually, this will be negative. I know these negatives cancel, but now we have another negative. So this is going to be minus. X is 4. So this will be 4 times 4. That'll be 16. And y is 3. So 16 thirds. Fraction inside of a fraction. Ooh, all right. And then y is 3. So 3 squared is 9. All right, there's a few ways you can get through this. You wouldn't be allowed a calculator for this problem. So a few ways you can get through this. Here's what I would do. I would just multiply the numerator and denominator by 3 because I would want to cancel that fraction out. That is what I would do. If you thought about this a different way, that's fine. Everyone's brain works differently. This is what I would do. I would just try to cancel out the fraction. So multiplying a 3 through here, that's going to give us -9 minus 16. These 3's cancel. That was the whole point. And then down here, 9 times 3 is 27. And so that's going to be -25 over 27. So phew, let me recap that one because that one was a lot. We did the derivative, then we did the second derivative, and then we plugged in this point that they gave us. And so that one was A.